This is lesson 6 of chapter 5, add linear equations, and we go back to our essential question, how can you use numbers and symbols to represent mathematical ideas? And throughout this chapter, you've noticed that we've been uh, dealing with algebraic expressions, variables, okay, defining variables, and the like. And this lesson is no different from that. So we will be looking at a lot of mathematical ideas, okay, and symbols or variables which will represent those. Uh, in this lesson, we will learn the term what a linear expression is, okay, and our objective for this lesson, probably some objectives in this lesson that you will be learning. Okay, I will learn how to use algebra tiles to add linear expressions, and I will learn to find perimeters that include linear expressions. So those are the two things that we are going to accomplish by the end of this lesson. Okay, so let's take a look at the real world link. Luke has 20 math problems and 11 science questions for homework. Cameron has 23 math problems and 10 science questions for homework. Okay, so Luke has 20 math problems, 11 science questions. Cameron has 23 math problems, 10 science questions for homework. The expression below represents the types of exercises that Luke has for homework. So again, he has 20 math problems and 11 science questions. Okay, complete the expression that represents the types of exercises that Cameron has for homework. So again, just going back to the problem, we know that Cameron has 23 math problems and he has 10 science questions. Okay. So in number 2, write an expression for the total number of math problems and science questions for both boys. So again, if we look at Luke, which he has 20 and Cameron has 23, therefore the total math problems both of them will have will be 43, 20 plus 23. And then for science, Luke has 11, Cameron has 10. So the total questions they will have for science will be 21 science questions. Okay, now let's see how we relate this to algebra. Okay, suppose Luke has X math problems and 5 science questions for homework, and Cameron has X math problems and 6 science questions for homework. So the algebra tiles below represent the total number of math problems and science questions for both boys. Okay, write an expression in simplest form that represents the algebra tiles. Again, the first one, this one represents Luke. Okay, and this one represents Cameron. So if you look at our algebra tiles, it'll go back to the words of the problem. Luke has X math problems. This is it, X, and 5 science questions. 1, 2, 3, 4, 5. So the unit tiles represent the science questions. The X tile represents the math problems. Okay, Cameron has X math problems. That's the one, and he has 6 science problems. 1, 2, 3, 4, 5, 6. Okay, now if I'm going to count the number of X tiles I have, okay, I can write the expression 2x because there are 2 X tiles, so I write 2x. And the number of unit tiles that I have, which will be 5 plus 6, which is 11. So I can write the expression plus 11. So if you notice, this represents the total number of math problems they have. Okay, 2x, okay, 1x for Luke, 1x for Cameron, and 11 science questions, 5 from Luke and 6 from Cameron. So this is the expression that is being asked when we represent the algebra tiles. Okay? Okay, let's take a look at the lesson proper and let's see how all of these work. Okay, so first we need to talk about what a linear expression is. So a linear expression is an algebraic expression in which the variable is raised to the first power and the variable are not multiplied or divided. Okay. Again, this is a very important definition because you will carry this on in high school. You carry this over in high school, this knowledge of linear expression. It's an algebraic expression in which the variable is raised to the first power only, okay? And the variable are not multiplied or divided. The table below, okay, gives some examples of expressions that are linear and some examples of expressions that are not linear. Let's take a look at some linear expression examples. 5x is a linear expression because the exponent of x is 1. 3x plus 2 again is a linear expression because the exponent of x is 1. And x minus 7 is another linear expression because the exponent is 1. Remember what an algebraic expression is. Okay, algebraic expression are numbers and variables, okay, separated by an operation, one operation. Okay, so that is a linear equation because now you have a variable whose only power is being raised to 1. All of them are 1. Okay, so take a look at some nonlinear expressions. Okay, 5mn is nonlinear. Okay, simply because it's saying the variable should not be multiplied or divided. And in this case, m times n is being multiplied. So that's not a linear equation. 3x cubed plus 2 is nonlinear, simply because the exponent is 3. X to the fourth minus 7 is nonlinear because, again, you have an exponent of 4. So if you have, okay, an expression where you are multiplying the variables, that's not considered to be a linear equation. Okay, and if the exponent of the variable is greater than 1, again, that is not a linear expression. Okay, so we define that. You can add linear expression with or without models. Sometimes you will need to use zero pairs. Let's see what that sentence, those two sentences mean. Okay, so let's add 2x plus 3 plus x plus 4. Okay, so if we are going to use models for 2x plus 3, this is how 2x plus 3 will look like. Okay, so you have 2x, 2x's, and 3 unit tiles, so that's 2x plus 3. And if I'm going to add x plus 4, this is how x plus 4 will look like. Okay, that's 1x, and these are the 4 unit tiles, so that's x plus 4. That's how we model the linear equation. Okay, looking at it again closely, and if we're going to add it, okay, we're going to combine. We're going to put all the x tiles together, and we're going to put all the unit tiles together so we can add them. Doing that, this is like we have your 3x tiles, okay, and all the unit tiles on one side. So this is your 2x right there, and this is your x right there, okay. Add 3 plus 4. This is your 3, and that's your 4. So if you notice, if I have 2x plus x, I add them together, they have 3x, okay? So doing that, 2x plus 3 plus x plus 4 is like equal to 3x right there, plus 7 right there, okay? Okay, let's take a look at another example, example number 2. Example number 2, we are doing subtraction, so we need to incorporate the definition of subtraction. Again, let me refresh your memory. The definition of subtraction is simply when you have a minus b, it is the same as a plus negative b. That is the definition of subtraction. Let's do that for number 2. And now we have 2x minus 1 plus x minus 5. Okay, I just copy this down here. Okay, and then by using the definition of subtraction, 2x minus 1 becomes 2x plus negative 1, and x minus 5 becomes x plus negative 5. Okay, we can add them vertically. Okay, and make sure we arrange the terms in columns. Okay, so basically we are arranging the terms in columns, meaning the like terms are arranged in each column. So let's take a look at how that works. You have 2x and x are like terms, so we arrange them in that column. -1 and -5, okay, are also like terms. We arrange them in this column. So when we do that, again, 2x plus x will give us 3x because they're like terms. And -1 plus -5 will give us -6. So 2x minus 1 plus x minus 5 is the same as 3x plus -6. Okay, again, using the definition of subtraction, too many addition subtraction signs. 3x plus -6 is the same as 3x minus 6. Okay, do the got it problems A and B, and let's see if you understand examples 1 and 2. Let's take a look at example number 3. Find 2x minus 3 plus -x plus 4. Use models if needed. Okay, so let's use models first, and then we'll go to example number 4 where we don't use models. Okay, so let's model 2x minus 3. This is how 2x minus 3 looks like. You have 2x tiles. Since it's minus 3, that means you have 3 negative unit tiles. Okay, on the other hand, you have -x plus 4, so you have a negative, okay, you have a negative x tile right there. That's -x plus 4 positive unit tiles. So these are your 4 positive unit tiles. So again, here we can actually use zero pairs to work out this problem. So again, what we will be doing is we'll be combining all our x tiles and we'll be combining all our unit tiles. If we do that, this is how it's going to look like. When we combine all our x tiles, this becomes our zero pair because x plus -x is 0, so that cancels out. And if we combine all our unit tiles, okay, we have 3 zero pairs, 1, 2, and 3. So these are our 3 zero pairs. So we cross that out, that becomes 0, and we're left only with 1 unit tile. So if you notice, only x and 1 are left. So the answer is x plus 1. 2x minus 3 minus x plus 4 is x plus 1. There you go. Okay, so let's take a look at example number 4 and let's see how this works without models. Okay, remember we studied the distributive property in lesson 5, I believe, or lesson 4? Lesson 4. Okay, so we will be using the distributive property here. We will distribute 2 to x and 2 to 3, okay, before we can simplify this particular expression. Okay, so first things first, okay, we copy the problem down. This is highlighted in red because that's the number that we are going to distribute to x and 3. So if you notice, that becomes, okay, if I multiply 2 times x, I end up with 2x. If I multiply 2 times 3, I end up with 2 times 3 right there. And we can simplify that further. And we simply copy 3x plus 1 right there. So simplifying the expression, 2 times x is 2x, 2 times 3 is 6. Simply bring down 3x plus 1 right there. Okay? Again, we add them vertically, meaning we line up our like terms in columns, and this is how it's going to look like. So you have 2x plus 6, which is that one, and I add 3x plus 1, which is that one. If you notice, the like terms have been lined up in each column. So now, since they're like terms, we can add that. 2x plus 3x is 5x, 6 plus 1 is 7. Okay, so 2 times the quantity x plus 3 plus the quantity 3x plus 1 in simplest form is 5x plus 7. Okay, let's take a look at example number 5. We want to find 5 times the quantity x minus 4 plus the quantity 2x minus 7. Again, we need to use the distributive property. We need to distribute 5 to x and negative 4. So again, 5 is in red. So you'll know that it's being distributed to x and to negative 4. Okay, so if we do that, 5 times x is 5 times x. And then you have 5 times 4 right there. Okay, and we simply copy 2x minus 7 on the other side. We simplify that. We now know that 5 times x is 5x. 5 times 4 is 20, so this becomes 5x minus 20. We simply bring down 2x minus 7. Again, we arrange them vertically, meaning we line up our like terms in columns. So with the 5x has and 2x are like terms, so we line them up in a column. Negative 20 and negative 7. Okay, we also line them up in a column. Okay, so if we add that, 5x plus 2x will give us 7x. Negative 20 plus negative 7 will give us negative 27. Or basically, this becomes 7x minus 27. Okay, so what I was saying is this becomes now, if I'm going to add this again in another way, this is 5x. Let me do that again. Remember the operation when it comes to addition and subtraction, the operation of the number is the sign of the number. And that's the reason why I keep on saying this is negative 20 and this is negative 7. Okay? So when it comes to addition or subtraction, the operation before the number is the sign of the number. So this becomes 7x plus negative 27. That's what I meant, which is the same as 7x minus 27. Okay? So this is more simplified than this because you have too many addition and subtraction signs going on there. So when we have 5 times the quantity x minus 4 plus the quantity at 2x minus 7, okay, the sum is 7x minus 27. Okay, do the guided problems and let's see if you understand examples 3 to 5. And finally, one word problem, and we'll talk about perimeter. Okay, and in this problem, okay, it's asking us to write a linear expression in simplest form to represent the perimeter of a triangle. Okay, that's the first thing we need to do. Write a linear expression in simplest form. Okay, and the second thing we need to do, find the perimeter if the value of x is 5 centimeters. Okay, first and foremost, we need to understand what perimeter is. Perimeter simply means the sum of all the sides. So when you talk about the word perimeter, okay, generally speaking, okay, if you find perimeter, okay, by finding the sum of all the sides of a polygon. Okay, a triangle is considered to be a polygon and it has 3 sides. Meaning, if I am going to find the perimeter of my triangle, I am going to add all of these 3. Okay, so finding the perimeter means adding this side plus that side and that side. So we first write the linear expression for the perimeter of a triangle, meaning we're adding all the sides, which is 3x minus 3 right there, plus 2x plus 9 right there, plus 5x right there. Okay? So rearranging the terms using our properties of addition. This is the I am using the commutative property of addition. I have 3x plus 2x plus 5x, okay, plus negative 3 plus negative 9. Okay, so I put all like terms in parentheses, okay, on both the x's with with the variable x and the constant. So I put the constants together because they're like terms, and I put uh, my linear expressions together because they are like terms. Now, remember what I told you, the operation before the number is the sign of the number. If you notice, this is minus 3, so the sign of 3 is negative, and that's how you see it there. Okay, that's the reason why this is negative 3, because the operation before the number is the sign of the number. Let me write that down, and you need to memorize this. Again, algebra, here we come. Okay, so in addition or subtraction, the operation before the number or expression for that matter is the sign of the number, is the sign of the number or expression. Okay, copy that down, pause this video, copy that down because that becomes very important once you start adding and subtracting linear expressions. Okay, so going back here, okay, we put all our like terms together, put our constants together because they're like terms. 3x plus 2x plus 5x will give us 10x, okay, and negative 3 plus 9 will give us positive 6. So negative 3 plus 9 is positive 6. 3 plus 2 plus 5 will give us 10x. Okay, so that is the perimeter. Okay, we just wrote a linear expression representing the perimeter. So this is our linear expression representing the perimeter of this triangle. So this triangle's perimeter in a linear expression is 10x plus 6. So the second question that's being asked of us, find the perimeter if the value of x is 5 centimeters. So all we need to do, since value of x is 5 centimeters, basically saying if x is equal to 5. So we get that 5 and we substitute that to our x here. So what happens now is that knowing that the perimeter is 10x plus 6, we simply substitute x with 5. So 10 times 5 is 50 plus 6 is 56. So the perimeter of this triangle when x is equal to 5 is 56 centimeters. Okay? Do the last got it problem and let's see if you understand example number 5. And that's the end of our lesson. Thank you for watching.